Hello again, everyone. Dr. David Block here, reviewing our practice unit exam on mole ratios, stoichiometry, and types of chemical reactions. This is going to be the last of 3 videos, and I hope that they were successful in helping you erase any misunderstandings on the unit. Here we go. Number 17. Given the unbalanced equation, we have a certain number of nitrogen gas particles and hydrogen gas particles combining to form ammonia gas. Well, when the equation is balanced using the smallest whole number coefficients, the ratio of moles of hydrogen consumed to moles of ammonia produced is, let's do this. This is no different than our other problems. On the left side we have 2 nitrogens, we have 2 hydrogens. On the right side, we have 1 nitrogen, 3 hydrogens. Well, let's play around and double what's on the right. In doing so, we end up with 2 nitrogens, 6 hydrogens. And on the left, if we add a 3 here, then that becomes 2 nitrogens and 6 hydrogens. It balances. So they are asking us to determine the ratio of hydrogen consumed reactants to ammonia produced. So we end up with 3 hydrogens to 2 ammonia, so that is a 3:2 ratio. Okay, ladies and gentlemen, this question, number 18, appears to be complex on the surface, but if you pause, take a breath, and think, it will be a lot easier than you anticipate. Alright, here we go. Given the unbalanced equation, the balanced equation representing a reaction. Okay, calcium oxide combined with carbon dioxide to produce calcium, I believe that's calcium carbonate, and it's releasing heat. The question is, what is the total mass of calcium oxide that reacts completely with 88 grams of carbon dioxide to produce 200 grams of calcium carbonate? This happens to be a law of conservation of mass question. It has nothing to do with gram formula mass or what have you. It wants to know how much of calcium oxide is combining with 88 grams to produce 200 grams. In other words, what is this? So it's 200 minus 88 equals 112 grams. Law of conservation of mass. Number 19. These are great questions because they're showing you illustrations to demonstrate a story. It reads, given the balanced particle diagram, here we have an element combining with 3 separate elements of the same type to reformulate, recombine, reconfigure, whatever you want to call it. It has now become new substances. They've rearranged. So which statement describes the type of change and chemical properties of the product and reactants? Well, is this a physical change? Well, quite frankly, yes, physical changes will occur. But what's most important is the atoms have rearranged each other to become a new substance. So we are looking for something that suggests a chemical change. 3 and 4 say that. So 1 and 2 are gone. So now, what's the difference between 3 and 4? They're both about chemical changes, and number 3 says with the product and reactants having different chemical properties, different substances, different properties. Sounds good, but what does number 4 say? Well, they have chemical changes with the products and reactants having identical chemical properties. That can't be. The answer must be number 3. All right, we're on the home stretch now. Number 20. Here we have magnesium combining with hydrogen chloride aqueous. We haven't gone over it yet, but when this stuff is aqueous, That's hydrochloric acid. Now, one thing I did not like about this question is the arrow going in both directions. Let's make it just go to the right only. Now, what's happening here? Well, we have a new substance being formed, magnesium chloride and hydrogen gas. So it appears as though the magnesium is taking the place of the hydrogen, kicking the hydrogen off. What do we call this? Well, we call it a single replacement reaction, and it also resembles this. If we have A plus XY yields maybe AY plus X, there's your single replacement reaction. Number 21. Given the incomplete equation, we have two dinitrogen pentoxide gases. Well, what could they become? All right, so we are looking for, well, let's see what it says. Which set of products completes and balances the incomplete equation? So we're looking for something on the right that represents all the atoms on the left. Well, how many nitrogens do we have on the left? Nitrogen, we have 4 moles of nitrogen total, and oxygen, we have 10. We need to have one of our answers to account for all of them. So which one? So this has 4 nitrogens, this has 4 nitrogens, this has 4 nitrogens, and so does this. Quick inspection, sulfur. Where does that come from? Doesn't materialize out of thin air. Alright, so choice 1, 2, and 3 have 4 nitrogens, looking for 10 oxygens. Let me undo a lot of this so we can look at the oxygens. Hydrogen. Can't be. No hydrogens on the reactant side. So, we're down to 2 and 3. Which one of these represents 10 oxygens? 4 oxygens. Can't be. Let's confirm that we have 10 oxygens here. From this location here, we have 8 oxygens. Here we have another 2. 10 oxygens. The answer must be 3. And lastly, we have a question that asks you to take the name of a formula and write its actual formula. Might be helpful to have periodic table handy. We're looking for chromium 3 oxide. Chromium. Where are you, chromium? There you are. Chromium. Chromium 3 oxide. So the 3 tells you that you must use the +3 variety. Right here. +3. Not the third one down, but the +3 itself. Oxide, we're dealing with oxygen. And oxygen has a -2. So it tends to gain 2 electrons. Let's see how this works. So we have chromium, there's the pen, chromium +3, oxygen -2. If you recall the crisscross method, we drop we drop the sign, and we move the number down. It would be 2 moles of chromium for every 3 moles of oxygen. It would be C2O3, choice 3. Well, ladies and gentlemen, please review these as often as you need to master them so that we can be successful on our unit exam. Good night.